here. This is an extra, just little discussion I want to make about Max and the assignments that are the ones due on Friday, and then this plays into the ones that will be due later on in our semester. So, just backing up, the assignment is asking you to create a composition. And perhaps some of y'all in the class might be like, well, what do you mean a composition? Didn't we already do that with MuseScore? Or like, how is this a composition? Well, it has been my wish to kind of complicate these matters a little bit, to get us to consider that there are other modes of communication, expression, and performance that are a little different than some of these prescribed Western practices. And so, while we're not using Western notation and a software that highlights Western notation practice, we're actually creating some kind of like little environment that is going to produce sound. And we're coding it. Now, is that a piece? Well, it depends on how you're defining these things. And not to be too expansive or too, to be too meta about everything, but what do we mean by piece or composition or even performance in our music making? Like, what do we actually mean by that? And does a bunch of MIDI bleep bloops in our max patch equal a performance? Well, I'm inclined to take a more expansive view of these things and say that there is a performative aspect to this. But to do so means we have to reconfigure how we think about composers, composition, performers, and listeners. More on that later. So when we're thinking about this piece, right, it has multiple aspects to it. One of the things is we want to make sound using some of the MIDI stuff in Max. And we also want it to have some level of interactivity. And when I say interactivity, I mean very basic, like I'm pushing a button that starts it. But let's back up a second and let's think about how we can start our thinking here. So remember that in Max we have objects like a bang or a button. We have objects like a toggle. And then we were using common objects like metro, and we were using counters, and we were using select. And then we were chaining these things together to do certain, to basically do a task in a certain frame of time. And that frame of time is one that we're determining. Again, this is different than how we were thinking about music composition through MuseScore, and it will be different than how we're thinking about it in terms of DAWs and songwriting, beat making, etc. The thing I want to say about this too is consider that in Max, you can create an environment for somebody who, how do I say this? Someone who is new to music making, or someone where you need to kind of augment their ability to interact with the software or interact and make music. You can create an environment that is bespoke to whatever their needs are, right? And so consider a larger picture here. Anyway, so check it out. This is kind of, again, this is like the starting point for how we're thinking about building these little sequencers, but I'm going to show you a couple extra things that might spur your creativity for this project or future ones. Okay, so I got my toggle. I'm going to plug it into my metronome. I'm going to add an argument to my metronome. Remember, it needs an argument so that there's a discrete time interval that it's sending bangs. So I'm going to use, arbitrary 300. And I'm going to put a bang or a button after it. I'm just resizing it so you can see it more easily. You don't have to resize it. You can make it whatever size you want. So it goes in there. Let's make sure it works. I've locked the patcher so I can interact with these buttons. Boom. And yeah, there it goes. It works. Great. Fantastic. I'm going to unlock the patcher so that I can interact. I can make things and modify them. And then I'm going to use our classic counter object, And again, I'm going to make some steps in here. Yeah, let's do 1/16. And then we need an integer box. I for integer plugs in there. Current count is right there. And then plug it in there. Okay, and then turn it on. I lock the patcher. It's locked down here. By the way, if you see me locking or unlocking the patcher without clicking down here, I'm holding Command on my Mac keyboard and then clicking anywhere that's not an object. And I can lock or unlock the patcher because I need to move faster than going down here. Okay, and it's keeping count. And because it has an upper limit of 16, it's gonna go back to its starting point once it reaches 16. Okay, cool. So remember that this was our basic setup, and you can refer to that max patch. It's on, it's in our files from I'm sorry, I'm going to be clearer. The max patch that we made in class that has like multi-sliders and all kinds of stuff, that is in Canvas, and it's on our class website. And remember, can you pull from that one? Yes, you were encouraged to. But please modify the message boxes or the integer boxes to make your own little sequence composition. P.S. Remember that from that, you can copy and paste things. You can also select things and hit Command D for duplicate, and it makes a duplicate. So you're not limited to one sequencer. You can make a whole bunch of them. You can make a whole machine that operates a certain way, or perhaps gives the listener performer options to engage with it in different ways. Like, what if I turn on one sequencer and then I have the option to turn on another at a certain point? It's an option, right? Remember that comments can be helpful. Please click this toggle. That was C for comment, and you can just put it anywhere and move it around, whatever. Okay, so we've done this in class, and then down here to route these things, we're going to use select, and then we're going to use, this is tedious, I should have done like 8, but anyway, I'm going to make a whole bunch of integers that it's listening for. Why do I need all of these? Because the select object is listening for the integer coming through the system. And when it detects that one, it'll send, like, if it detects 1, it'll send a bang out through that outlet. And it tells you, see the text down there? It tells you, bang if input matches 2. So what's coming in is the number 2. It sends a bang through that outlet. Pretty nifty. And remember, from there, we had bangs, and then those bangs, and I'm actually just making these bangs so we can see them light up. Let me just make a few of these. Okay, and I have 16. I don't know why I made 16, but anyway, we're doing it live. So, and then I plug in all these. Let's make sure that these initial ones work. So we're gonna watch for it. Oops, I didn't connect it. Silly. Now we're watching. Yeah, hey. And then if I plugged in the other ones, they would be lighting up also. And then that's our timekeeper. And then this is going to go out to a make note object. And remember, you can put the arguments in here, or you can make them separate integer boxes that override those written ones. Make note, note out to make a MIDI sound. And I'm going to make it MIDI channel 1. Remember, we have 16 MIDI channels we can use. Make note. I'm connecting the pitch and the velocity. Yours should look like this one in your patch. If you want it to make sound, it should look like this one. And then I'm going to have, I don't know, 46. And then I'm going to have, I don't know, 52. And I'm going to have these message boxes here. Boom. Boom. So the bang is sending an impulse bop, 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 through the cable to the message box. Message box sends that integer into the pitch inlet, and it's going to go around. Aha, so we heard those 2 notes. I only connected 2. There they are, right? So that's the start of it. Remember that the other things in that class max patch that I made in front of y'all has some other ways to manage data. So that's really what we're playing around with, right? Is we're routing and sending data through these objects. And this data tends to be just simple integers right now of our own choosing. And we can represent those things using like a multi-slider object. We can use live.grid, which we made those changes to live.grid. I'm going to walk through that in this one in case you want to use that one too, where that one is actually just interpreting if something is a 1 or a 0 and then sending a bang to another integer, right? Now, I want you to consider, think about this, not necessarily for this assignment, but just think in general. We're kind of choosing these integers according to certain compositional ideas. We are stuck in 12-tone equal temperament with MIDI 1.0, the way it is. There are workarounds, P.S. There are other things we can do to arrive at other scales, but just for right now, we are stuck in that world. And I want us to consider other places that data could be sourced from, because right, we're just playing with simple integers, right? So where else could we get data? This complicates the issue about performance, instruments, and, dare I say, musical impulses. Do you ever think that data that represents you as a person is like flying around the internet at all times? There's data that we could use to represent ourselves, the weather, statistics, all kinds of things that we can pull and use as material for our max patch. I know that might sound a little crazy, but when you think about it, the world, both the natural and the digitally interconnected one that we've constructed on the internet, possesses plenty of material for us to build sequences and build musical ideas. So that might not seem apparent because we're just playing around with MIDI notes, right? But it's something to think about, that we're basically sonifying data. I'm gonna say it again. We're sonifying data because there's nothing about 46 that's intrinsically musical, except in this situation, the integer 46, the one right here, is being sent to an object to interpret that as a musical note. Okay, continuing on. So I want to say this, because this is a little bit overlooked in our class, unfortunately, because we were just down in the mud just trying to get this thing to work. What I want to say is the counter object has some cool features that I hope you checked out. And if you didn't, that's okay. I'm going to unlock the patcher, and then I'm going to look down here, and I've got underflow, counter hit minimum. I've got counter hit maximum, and I've got carry count. I'm going to hook up some bangs to this, and let's see if we can figure out what they mean by this. Can you hypothesize what they mean by this? Let's find out. Okay, because it's counting up, it's going to send a bang when it reaches the maximum. If we were counting down, it would send a bang when it counts down to the minimum, the lowest number, right? But in this case, because we're just counting up, it's only going to send a bang when we hit the top one. What is carry count? Well, we're going to hook up an integer box to that and see what it's doing. What do you think it's going to do? Hypothesize. Okay. Here we go. It's putting a number in there, isn't it? Now it seemed on our screen like it jumped to 10, but that's because now look, now it's linear now. That's not abnormal. That's because that sequence already ran 10 times before I hooked that up, and the counter object was keeping track of it. How do you reset it? This inlet. Resets counter to number immediately. Put a bang on that one, boom, and then bang, and it resets. It reset the count, and it reset the position of the counter. So now when I go, we're going to see it increase linearly. This will be n plus 1 each time now. Okay, how is that useful? Well, what if you wanted a sequence to just run 3 times and then stop? Can we do that? Yes, there's 2 options. I'm going to move this one over here. There's 2 options for us immediately. There's actually other ones, but here, this is the easy one. Select 3. I'm sorry, I want to say select 4. Select 4, because when it hits 4, right, that's when it will stop. Okay, so select 4. Now listen, we need this to go into the select because the select is listening for 4, and when it detects that this thing is 4, because it's listening, it's going to go up here and turn this off. Let's test it out. I bang to reset, and let's hit it. I should have just done 8 steps. Oh well. Okay, that's 1 time through. It's 2 times through. Hey, and it stopped itself. Remember, you can also use, if you like if statements, you can do this one. So with this object, we want to, basically if any number goes in, it'll bang. But we want to evaluate for a specific number, we have to add this text. This means if integer 1 coming in equals 2, then bang. Let's test it. 2, then it'll bang. I've reset this, so it's going to go through its sequence. We can see the counter going 1. And now it gets to 2, and then it turns off. Okay, so check it out. We can put some other options in here. So let's double click it. This is the right click or 2-finger click on a touchpad. Open if help, and we see some of the statements that we can use. And these are ways to test things against one another. And so in this example right here, if I make it's checking to see if integer 1 is less than 2. And check it out. If integer 1 is less than integer 2, then send the message less. Else, anything else, send not less. In this case, it's just updating the text in here. And notice that now 8 is definitely not less than 7, but 6 is less than 7. But this less thing came from this text in the argument. Okay, what are some other conditionals? Let's say if integer 1 is greater than 0, then display the number. But if it's not, then don't display the number. See what I'm saying? If I go below 0, that is not greater than 0. And we're not caring about absolute value here. We're saying that is not greater than 0. But now, this is a way we can kind of put a limit on things, right? How interesting. Okay. Now, here is the one I really care about for us. We have if integer 1 is greater than 0, then send that number through. Else, output 2, send the number over here. I'm going to say that again. If integer 1 coming in is greater than 0, then send that down here. Else, output 2, put the number over there. Let's test it out. So it's greater than 0. Look, it's going to that first outlet. That's assumed it's going to the first outlet. We don't need to put out 1. It's understood. If I go below, though, it sends it to output 2. I hope you're already thinking about ways you could make conditional statements operate your sequencers. And that's a little more advanced, but I'm just It's food for thought. Maybe you do it on this assignment, maybe you don't, but this is something you can consider for future things. Okay, we have this one. If integer 1 is greater than 0, then display 1, else display 0. Yep, it's greater than 0, display a 1. It's below 0 now, display a 0. Multiple conditions. This one, and now we're back in math class, right? Okay. If integer 1 is greater than 0, right? Then display non-zero. This is saying, this is a unity here. This is saying that if integer 1 is greater than 0 and integer 1 is less than 0, then display the text non-zero. Else, it's 0. So wait a minute. There's only one situation where it'll display 0, and that's if the incoming number is neither greater than nor less than 0. It's equal to 0. And that seems to be true. Yep, and look, it's true. -7 is less than 0, so it's satisfying this statement. And that little symbol, that double line, on your keyboard, that's above the enter button, the enter key. And you have to hit shift to get that. Do you have to use that in your assignment? No. No, you don't have to, but it's available. It exists. And it might give you more options than just using a select, right? Okay. Yep. If you read through the help manual, sometimes there's like silly things in some of these max patches. I love it. Anyway, so that's an option to create an extra layer of like, oh, I want you to repeat this 2 times and then go away, right? Do you have to use that? No. You could also just be like, hey you, hey person, play this 2 times. That's cool. I dig it. Yeah, for sure. You can also be like, press me. Not an object, sorry. Press me, and then like something happens, and right? So that's what I mean by creating a greater level of interactivity with these things. We're going to talk more about this in class. If these things seem really complex to you, remember that you don't have to use all the things we talked about in this little video. These are just options that can give us a little more interactivity. Oh, let me just change this one here out to bang. So by the way, I changed this one. So this is if input 2 matches 3, then send a bang. Else send an output. Okay, so just finishing this idea, if you have a statement that's like this, it's a little bit complicated. What we actually need to do for this one is plug it into both. I know it seems kind of weird. The way it behaves is if you just send it into the cold inlet, it won't send a bang through, so it won't actually be evaluating. And so I'm actually going to do away with this bang. I don't need it. So I'm going to go over here and look. Input 2 going in. It's not equal to 3. It bangs the second output. But now it is equal to 3 and it bangs the first output. So you can set up these conditional statements to actually affect the interaction between different sequencers. You can also pair this with like a random number generator and say random. And let's say that the random thing is going to generate steps here, and then I put a metro on it, and let's send a bang every second. Okay, great. And let's put a toggle on it. Yep. And then, or I want to see the integer it's sending, and then what I'm going to do is I'm going to connect that there, and see what's happening now it's going to send bangs out selectively according to the input it's receiving. What if, right? Let's disconnect this one and let's actually send it in here. What if we initiate both of these processes at the same time? Toggle. A toggle controlling a toggle? Yes. Why not? What's happening? Well, right now, this is listening. It's evaluating if input 1, the integer in input 1 is matching 2. And if it does, it sends a bang which turns this on or off. This guy's running continuously, and then this one is just evaluating whether that's going to turn on or off. So this could turn on or off at random times, just based on the random number generator. And we haven't had a 2 come up in a minute. There's 1. And then when a 2 appears again, it'll turn it back on. So again, we're creating a situation and an environment where things can happen randomly. They can happen, stochastically. They can happen according to instructions we give to the performer/listener. Yeah. One more thing. In class, we talked about using live.grid, and we were pressed for time. I just want to review one little thing really fast. If you want to use live.grid, be my guest. Live.grid, you just have to make a couple changes to it for it to work the way that we intend it to. So if I move this over here, I'm going to open the inspector. What have I done? I made live.grid, I clicked on it, it's highlighted, and then I opened inspector. In here, you need to make sure that these things are checked. I'm going to get rid of the directions panel. I am going to go down here, and I'm going to hit matrix mode. And then I'm going to change, for our purposes in this class, I'm just going to use 8 steps, and then I'm going to use 1 row. And then I can resize it. Now, if you click on these things with the patcher locked, it turns them on or off. This looks like a drum sequencer. And it's more than that, but it can operate that way. We've made it so it can operate at just as simple steps. So now what we're going to do is create our typical, yep, you guessed it, metro, and then we're going to plug in a counter 1 8. Metro counter toggle. I'm going to put a integer into the metro to change the speed of it, and then this might not seem obvious, but you plug the counter into this dog here, and it's going to light up. So what it's doing is it's evaluating if that step is lit up or not. We don't really have velocity with this guy. We just have on or off. It is either 0 or 127 if it was evaluating velocity. If it was. Could you make another thing that would change the velocity? Yes, you could. But for now, don't worry about that just yet. Now, how do you get that to make sound? Well, what we're going to do is we're going to send current step value. This one says integer current step value. You put it in there, and let's see if something changes. I lock the patcher to change some of those squares, turn it back on, and look. It sends a 1 if the square is lit up, and it sends a 0 if it's not lit up. Okay? And then what? Well, let's say we can either use an if or a select. Let's keep it easy. We'll use select. It's evaluating. If it receives the message 1, then it'll send, I don't know, 36. I happen to know that 36 will be a nice bass drum sound. And let's use note out 10. That's channel 10 reserved for percussion. Let's use make note, and we'll use 120 velocity, and a duration won't really matter too much unless it's cymbals. There it is. Cool. See if it works. and then, I am Iron Man, right? Okay, so we made a drum machine. That's for one sound. Now check it out. You can retain these two objects, and what you can do is move this guy off to the side. Sorry, this is getting a little cramped in here, right? Move these guys over here. Okay. And you could, I don't know, duplicate this and then plug it in to its own evaluator. It needs its own evaluator. We can do it this way. No, it needs its own.
Red light on.
Sorry, I have a patch that's open in the background, and it needs its own evaluator. It does need its own one. So slide one, blah 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 blah. Yep, and then, oops. Let's use. I don't know. I'm gonna put an integer for this one because I want to pick a sound. Let's find like a. Yeah, okay, a little snare sound. Cool. And then, I don't know, that's a choice. And then counter's gonna go in this one too. Now hold on a second. It's the same counter because it's evaluating the same thing, right? Now, let me back up. It's a counter because it's going through the same sequence, right? Even though we have two different live grid objects, I duplicated. But the evaluator down here has to be a separate entity because we only want it to send a bang when that one lights up. Right? There you go. So that's how you can use live.grid, kind of a more detailed view from our class where we were a little rushed at the end there. Anyway, I hope this video is helpful, and do your best with this assignment. Am I expecting something really complex? No. I just want to see that you are playing with the MIDI stuff and starting to think in this way, where you're making devices and making an environment where interactivity is possible. All right, please see me for office hours or send me an email if you have any questions. I'm eagerly awaiting your questions. And otherwise, I will see you next Tuesday. All right, have a good weekend.